and more to zero, equal and more. And then how do we know dia punya sign tu equal ataupun
Alright, good question. Okay, saya share screen sekejap ya. Okay, saya tunjuk ni lah contoh yang last from our previous class ya. So Jima asked why certain question we got the equal sign and then certain without the equal sign kan, the interval ya, whether it is less than equals to and so on. Okay, let's see the example previous one. Okay, let's say we take this one. Okay, so the interval where each function is increasing or decreasing. Okay, so from previous class, you can see my screen, right?
Yes, teacher, we can.
Okay, all right. So from our previous example here, we can see that if we have this function, we want to find the interval where each function is increasing or decreasing. Therefore, the first step we need to find the f prime, right? So f prime here is 3x squared minus 3. And then later, we need to equal our f prime equals to 0. Class, why we need to equal this equals to 0? Actually, when we equate f prime equals to 0, we are looking for what?
the gradient of turning point.
The gradient of turning point. Okay, yeah, is a turning point. We are looking for turning point. Kalau kita put it equals to 0, meaning we are looking for turning point lah. Yeah, ataupun we call it stationary point. Yeah, we want to find a stationary point. Then, therefore, we take the 3x squared minus 3 equals to 0. Okay, good. So with this, kita akan dapat interval dia. The x will be, if you factorize, we will x square minus 1 equals to 0. So 3x minus 1, x plus 1 equals to 0. Therefore, our x is equals to
1 and negative 1.
1 and negative 1. Okay, that is the idea. We have the negative 1 and 1. Okay, but at this particular point, yeah, this particular point, negative 1 and 1 is a stationary point where this is the point where our function will have the changes from increase to decrease or from decrease to increase, right? But if we think about the gradient, yeah, gradient of the function at that particular point, dia adalah, what is the gradient? What do you think?
0.
0, right? Because it's a turning point, or maybe we call it a stationary point, yeah, where we change this particular point will change our graph from increase to decrease, decrease to increase. Okay, what do you think? Will we need to include this negative 1 and 1 into our interval, or we just have to exclude?
Exclude.
Huh?
Exclude.
Okay, for us, we can see that it is much easier kalau kita exclude. But there is a two-thought, school of thought, whereas kalau kita refer Oxford will say we need to exclude. But if we refers to Hayes and Harris, they say it is supposed to be include. Okay, there are two of ideas on this particular point. But to make it easy, I guess if you can see here, we just exclude this particular point into our interval because we are looking for the interval whether it's increase or decrease, right? Increase or decrease. Therefore, we just focus on that because that particular point is the point where they have the turning point, sama ada dia increase to decrease or decrease to increase, okay, so kita akan exclude. But for the example I gave you, the one with the equal sign tu meaning include, that one is from the books of Hayes and Harris. So that is the different lah. Bila I show you, you got confused. This one with equal sign, this one without equal sign. But you just stick to without the equal sign. Okay? Dia memang ada confusion dekat situ. Memang ada macam mazhab lah kan. Kita ada a few mazhab kan. Macam tu lah math pun. School of this kata you need to include. And this one you need to exclude. I have checked this one already. So kita pakailah mazhab kita so we exclude. Alright? Boleh Jima? Okay, good. Okay, let's continue from our previous class. I gave you hold on Let's see. I give you one question, right?
Yes, teacher.
Okay, let's discuss. Okay, this question. Find the interval. Is this the one? Tak.
27, teacher.
Ya. Saya dah buka tadi. Hold on, where is it? 27, supposed to be 27. Okay, this question, right? Okay, we have here a function, 2x minus 3 over x squared plus 2x minus 3. Show that f prime x is equal to this and draw its sign diagram. Okay, how did you get the f prime? Okay, can I call your name and explain? Okay, I want Fatini. Fatini, how did you differentiate this one, Fatini?
Using quotient rule, teacher.
Using quotient rule. Okay, so what is your u?
U is 2x minus 3.
Okay, this is your u.
Okay. Yang bawah
This
tu.
one bukan. Saya sepatutnya ambil atas, sorry. Okay, your here denominator adalah u and denominator is your
V.
v. Okay, so what is your u prime?
U prime is 2.
2, v prime?
V prime 2x plus 2.
2x plus 2. Therefore, your f prime using the quotient rule?
V times U prime minus
x squared plus 2x minus 3. V times u prime is 2 minus 2x minus 3. U times your v prime kan? 2x plus 2 over
V squared. X squared plus 2x minus 3
squared plus 2x minus 3 squared. Okay, so you simplify, well you get same like what is given here. So you got 2x squared plus 4x minus 6 minus, this one is
4x squared plus
4x squared plus
8x plus 6.
4x squared plus
8x.
how many?
8.
3. This is 2x plus 2, 4, 3 plus 2. 3 times 2, 6, 4, yes. 3x minus 6.
6.
Okay, do we have bracket here ataupun this is the final one?
Ada bracket.
Yes. Okay, so over all this thing, x square plus 2x minus 3 square. And then you got what? This is 2x square minus 4x square. You got 2
Negative 2
x square. And then negative 4x minus 3x. And this is 4x. 4x minus 3x. Plus x. Betul tak? Negative 6.
Teacher.
Negative 6 plus 6. Okay, habis.
0.
So this is x square plus 2x minus 3. This one also you can factorize kan? So this one you factorize. If you factorize this, saya buat mistake ke? This is supposed to be negative 2x square plus 6x. Mana plus 6x? This one supposed to be negative, right? Yeah. Kan? So when it is negative, positive. Then you have what? Is it 3x?
Dia jadi 4x minus 6x. Kat situ. Kalau
Kat mana?
kembangkan je.
4x.
4x minus 6x.
Okay, minus 6x.
Eh.
Ini dia jadi 3, 2, and this. Yeah. Okay. So here supposed to be plus 6. This is negative or positive? Positive kan?
Dia jadi negative 2 teacher. X.
This is 2, 2, 3, 2. Oh, okay, okay. Negative 2 So dia jadi 4 plus 2. 4 plus 2, 6x. Yes. Okay. So you got negative 2, negative 2x times x minus 3.
3.
Yes. Yeah. So you factorize down there. X minus 1, x plus 3. Okay. Boleh Okay. So from here class, hence find the interval where y is equals to fx is increasing or decreasing. So from here, you equate to 0, right? So what is your value of your x? X can have what value? This is all 0. So x is
Negative 3, 0, 1, and 3, teacher.
this is negative 3. You got 0 and
1 and 3.
banyaknya 1 and 3. Okay, betul ke? The rest of you?
Saya dapat 0 dengan 3 je.
When you equate this with 0. So, this one multiplied by 0 is all gone kan? So, this is the only one yang we have here. So, negative 2x times x minus 3 equals to 0, betul tak?
Betul, teacher.
So, macam mana dapat ni? 1 and 3? Negative 3?
Sebab saya equate everything yang dalam bracket tu equals to 0. So saya salah.
Yang ini pun? Why? Why?
Tak tahu, teacher. Terbuat macam tu.
Tak tahu. Kenapa tak tahu? You must tahu. We have to find our stationary point when we equate our f prime equals to 0. Betul tak? Bukannya kita ambil yang denominator ke numerator ke equals to 0 only. This whole thing is equals to 0. So your f prime is this. Right? So when this whole thing is equals to 0, you punya denominator you bring to your right side will be 0. Multiply with 0 is nothing. So what is left? Negative 2x times x minus 3 equals to 0. Therefore, your x supposed to be 0 and x supposed to be Supposed to be
3.
3. Betul tak?
Betul
The
teacher.
rest of you? How about the rest of you?
Betul
Betul teacher.
So bukannya suka-suka hati ambil. Nampak je in bracket. You say that you equate everything with 0. Bukannya ambil satu-satu equal with 0. The whole thing. Your f prime is equal to 0. Ya? Seperti ni?
Okay teacher.
Okay. So from here. Okay. Who wants to continue? Jimah maybe 0 and 3 Jimah. So what is the interval? The function is increasing or decreasing?
Decreasing less than 3 and more than 0.
Okay, you say that less than 3, more than 0. Yeah? Kita tengok decreasing less than 3 and more than 0. Increasing.
Between 3 and 0.
So x between this lah, ni x x between 0 and 3. So kalau kita ada tadi 0 and 3 here. Okay, this is 0 and 3. So you try to test your f prime just now, substitute the value in between 0 and 3, whether it is negative or positive. Definitely it will be negative, that's why, positive, that's why it is increasing between this value kan. And this one less than 0 is negative, greater than 0 also negative. Ya, so kita tengok So this is what we have just now using the quotient rule. Yeah, we got all these things somewhere as part A given. So which is a sign of this. Okay, and then part B we have here increasing or decreasing based on this lah. So our value increasing. Okay, what is this? Did I make a mistake? Okay, look, is increasing for x between 0 and 1. Tadi kita dapat 0 and 1 is increasing, positive. And then we have here 1 and 3. And then we have here decreasing x less than negative 3. Okay. Okay, cuba tengok balik semula kelas. Okay. Increasing and decreasing. Okay, if we let this f prime equals to 0. Okay. All right, look at this. If we have our f prime x equals to 0, just now, we have this whole thing equals to 0, right? Negative 2x, x minus 3 over x minus 1 square, and also x plus 3 square equals to 0. The idea of equate our f prime equals to 0, we want to find the stationary point. Okay, therefore from here class, tadi saya kata, this whole thing you multiply with 0, so what is left? Kita ada only, we have only what? 0 and 3. 0 and 3. Okay, now class, cuba kita plot sekejap. Kita punya function ni, I want to show you. Oh, sekejap I get my calculator because I leave it at home. Okay kelas, cuba you all upload this in your GDC. Kita nak tengok sekejap. Dia ada a bit ni this question. Okay, sekejap lama pula nak buka. Kenapa tak boleh ni? Memang have you plot your graph? Okey, kita nak tengok sekejap ya. Okay, let's see. We try. Okay, our graph of 2x minus 3. And then x squared plus 2x minus 3. I see. Okay. So, okay. Fatini, can you tell me what was your idea before? Bila you cari ni, you equatekan the denominator ni pun, you take 1 by 1 equals to 0. Fatini?
Yes, teacher.
How you come up with the idea? Did you plot the graph first?
No.
No. And then?
Actually tu silap je teacher, saya ter-equate dengan 0. Tak terfikir apa-apa pun time tu, ter-equate je.
Tak terfikir apa-apa pun tadi. Okay, class, when you plot your graph, did you see kita punya graph tu ada 3 kan? Right. So, if we are looking at this curve, definitely if we want to know the graph is increasing or decreasing, kalau based on this, when you plot the curve, we know that at this particular point, sekejap, we try to trace. Okay, bila kita ada x is the minimum, x is negative. Okay, at negative 3, x is equals to negative 3, kita ada apa? When x is equals to negative 3, we got what there?
Asymptote.
Asymptote, right? Correct. Which means, if we got the asymptote here, we have another interval lah to be considered. And then if you go further, x equals to okay, another one. How many vertical asymptote that we have here from this curve?
2
Huh?
2 teacher.
Yes, 2. So satu kita nampak is at x equals to negative 3, lagi satu is x equals to
1.
1. Okay, alright, sorry ya. Tadi saya lupa nak consider this function. When you look at this function, what type of this function? What type of this function we have here?
Reciprocal.
Reciprocal, ya ke?
Rational.
Oh,
Rational, yes, you have rational kan? One function over the other function. Right. So, you punya denominator tu kalau if this is the case, dia tak boleh equate to 0, betul tak? Betul tak?
Tak tahu.
Kalau you punya denominator is equal to 0, if your denominator is equal to 0, the value, definitely it will be undefined. Kan? So kalau kita tengok kita punya function ni, dekat mana dia akan jadi undefined? When your x is equal to 1 and when your x is equal to negative 3. Betul? Bila kita consider this thing, so kita tak this graph is exactly when we see at this class, this graph to be defined, the value of x cannot be 1, the value of x cannot be negative 3. Kalau kita masukkan x is equals to 1, dia punya denominator tu satu dia dah jadi 0. So part of that is 0, so the total becomes 0 as well because you multiply, right? And then the graph become undefined. Right, and then another value that this graph become undefined when your x is negative 3. Kalau you substitute the value of negative 3 into this function, the denominator here. So negative 3 plus 3, it becomes 0. So you multiply with this function, x minus 1 tu, again it's become 0. So everything over 0, it become undefined. Yeah, so kat situ kita dah ada the asymptote, the vertical asymptote, right? So at this function, we can see that it cannot be, the value of x cannot be 1, the value of x cannot be negative 3. Yes, betul ya. Therefore, we need to consider this. So this one also, bila kita ada this thing, we need to consider as your the interval value. Kita nak tengok ya. So this is supposed to be negative 3. Another one we need to consider x is equals to 1. Correct. Yeah, we need to consider that because this one, these two value give your function become undefined. Yeah, so from here, so kita kena test jugalah. Tadi kita dah kata when we substitute the value between 0 and 3, ya, kita masukkan 0 and 3, ni tak jadi 3 lah kat sini. This is 1, this is 3 ya, dia jadi terbalik. Okay, alright. Bila kita masukkan the value of this is 0 and then another one is 3. Okay. And then if you try to substitute any value between 0 and 1, let's say it is half. So it is positive ke become negative? Let's say x is equal to 0.5.
Positive.
Is it positive?
Yes.
Yes. Okay. In between value between 1 and 3?
Positive.
Also positive. Okay, between negative 3 and 0?
Negative.
Okay, and then 3 and above?
Positive.
3 and above.
Negative.
Positive answer.
Positif ke negatif?
Positive.
Kita tengok saya punya ni ni. 0 and 1 positive, 1 and 3 positive, more than 3 is negative, below than 0 is negative, below than negative 3 also negative. So kat sini pun negatif. Tapi kelas, cuba tengok why we have at this particular point pun kita tengok walaupun dia negatif, tapi we have the points that. And here also, 0, 1 here, it is positive and positive. Betul? Okay. Kat sini kelas kita ada later, actually after a few slide ni, saya nak masuk tentang stationary point. Kat situ I will explain more. Actually dekat this particular point, kenapa dia ada interval here walaupun dia negatif-negatif, kita ada lagi point dekat situ, which is our stationary point. Stationary point ni dia boleh jadi turning point ataupun dia boleh jadi point of inflection. Okay. Kalau dia adalah turning point, dia macam 0 ni. Turning point meaning kita tengok the gradient from negative become positive. Which mean we will have the minimum point ke maximum point? Minimum point. Kan? So kat sini dia akan ada minimum point because we look at the gradient from negative change to positive. And also for 3 here. From positive, you change to negative. Here kita ada what point? What point is this?
Maximum.
Maximum point. But what happened to point 1 and 3 here? Sebab the gradient will be negative and negative. Okay? Okay, cuba kita tengok kat sini. Dekat sini, this graph will be something like this. And then dekat sini, graph tu akan macam ni. You nampak tak? Ini kita panggil point of inflection. When it is point of inflection, it will affect the concavity of the curve. Yeah, meaning that if you look at below the negative 3 ni, the curve is concave down. But for negative 3 and above, the curve is concave up. So point of inflection will affect the concavity. Tapi turning point will give us whether it is a minimum or maximum point. Okay, so same goes to at 1 here. Because you can see the gradient is positive and positive. Tapi we have a stationary point. Ya, semua ni negative 3, 0, 1, 3 ni is a, here we call it stationary point. So stationary point pula divide into two, whether we can have turning point or we can have the point of inflection. Okay, point of inflection will affect the concavity, but turning point will give us the minimum or maximum point. Clear? Boleh? So at this point here, kita dapat satu ni, kita tengok ni. This curve is concave up, but here, after one is concave down. Ya? Yeah? So ni adalah kita punya point of inflection ataupun inflection point ya. Negative 3 and also 1. Walaupun gradient dia tak berubah ya. Okay. Any question? Yeah. So for this case class, we see here, we go further. Okay. Okay, so from here, that's why kalau kita tengok the graph is increasing, it is between 0, 1, 1, 3. Actually, boleh je kita cakap from 0 until 3 if we are talking about increasing or decreasing. Tapi dekat sini, because they have the point of inflection, they split. Ya, yeah, they split kan? Nampak? X between 0 and 1, it is positive. Therefore, the curve will be increasing. And then from 1 until 3, the curve is still positive. Right? So, if it is positive, the graph is still increasing. Ya? Yeah? Tapi dia split dekat 1 ni because it has the point of inflection there. Okay? And we go further. If it is decreasing, definitely we can have x less than 0 and also x greater than 3. But the split into this, x less than negative 3 is decreasing, which is negative. And then x between 0 and negative 3 is also negative. It is also decreasing. So tadi kalau kita just consider we want to know our graph is increasing or decreasing, it is not wrong when we, what we did just now. Yang ni yang kita buat f prime x equals to 0. Dia tak salah sebab memang you akan dapat at point of 0 and 3. Itu adalah interval yang the graph is decreasing, increasing, and this one decreasing again. It is not wrong if you're talking about increasing or decreasing. But since here, they consider everything, ya. Sebab kita ada point of inflection as well. Sebab tu dia split the interval become like this. So maksudnya dekat negative 3 ni, dia adalah point of inflection. And also dekat 1 is a point of inflection. Tapi the interval semuanya less than 0 tu is all decreasing. Greater than x between 0 and 3, the graph will be increasing. Is that clear?
Teacher,
Yes.
point of inflection tu asymptote.
Dia bukan asymptote je mah. Point of inflection tu macam ni If we have this graph, okay, this curve tiba-tiba you ada macam ni. Okay, let's say this is the curve. Okay, point of inflection tu dia ada dekat in between here. Sebab you nampak tak, ini concave down. Tiba-tiba this is concave up. This the point where the curve tu berubah dia punya concavity. Ya, yeah, dia bukan asymptote. Right, Jima? Okay, later I have the definition later about the point of inflection and the turning point and all after this. Okay, so this is the graph just now. If you plot just now, so inilah graph kita tadi. Okay, alright. We will go further sebelum saya punya point of stationary point tu. So let's try this one first. To find the interval where fx is equal to L and x is increasing or decreasing, Kenneth states that f prime x is equal to 1 over x, which has sign diagram itulah below 0 is negative, above 0 is positive for f prime. He therefore concludes that fx is equal to ln x is increasing for x greater than 0 and decreasing for x less than 0. Explain the mistake Kenneth has made. Okay, what do you think? Can someone give the answer?
Teacher,
Yeah.
ada gradient ke? Ada x ni less than 0.
Apa yang pada X, Jimah?
Meaning x kan cannot be less than 0 actually for L and x kan?
Okay, X cannot be less than 0 for ln X. Therefore,
Salah lah kan yang tu. Decreasing for x less than
macam
0.
mana macam ni? Macam tu je. Okay, let's see here. Since our f prime x is 1 over x, because ln x, if we differentiate, we got 1 over x, right? So it has a vertical asymptote at x equals to 0, right? Boleh imagine the graph of ln x? 1 over x. You got an asymptote at x equals to 0, right? Okay, so from here, but the graph of ln x is like this. If you plot the ln x, this is the curve. Okay, all right. In this case, fx is only defined when x is greater than 0. Ini yang Jimah kata tadi. Our fx is actually ln x kan? Okay, so fx is only defined when x is greater than 0. So f prime x is only defined also when x is greater than 0. Okay, so sebab itulah ya kita Kenneth ni make a mistake bila dia kata the graph is increasing for x greater than 0. Yes, for x greater than 0 it is increasing and decreasing for x less than 0. So x less than 0 there is no graph. Yeah, there is no graph. Decreasing for x less than 0. Tak ada sebab graph kita ni hanya define for x greater than 0. Maka for x less than 0 there is no graph. Right? So that's why the mistakes here when Kenneth mentioned that decreasing for x less than 0. Okay? Boleh?
Boleh, teacher.
Alright, so this is what I want to tell you just now, the stationary point. Okay, class. A stationary point of a function is point where f prime is equal to 0. It could be a local maximum or local minimum or else a stationary inflection. Okay, so tadi I told you stationary point ni can be a point where it turn your gradient from positive to negative where you get your maximum, or from negative change to positive you get your minimum point, or maybe it is still positive and positive but it changed the concavity of the curve. We still call it stationary point. Yeah, concave dia from concave up to concave down ataupun from concave down to concave up. Yeah, so this one also we call it stationary point. Okay, a stationary point, at a stationary point, the tangent is horizontal. Yeah, so this sentiasa 0 lah, kan? Alright, so turning points. Turning point here, just now I told you, it will give you maxima or minima. Yeah, maxima, minima. And if this is the case, you can see here, yeah, point A, B, C, and D. Point B and point C, point B and C is your minimum and maximum, right? Okay, so the graph shown has the restricted domain from -5 until 6. For this particular graph, it refers to this graph. Domain dibagi from -5 until 6. You tengok point A and point B, the value of X. So that is the domain. So from here, we can say that, ni pun kita dah sentuh dari tu ya. A is the global minimum. It has a minimum value of Y on the entire domain. That is global minimum. D pula, D is actually global maximum. Yeah, it has a maximum value of Y. Okay, and then B, point B, local maximum. It is a turning point where f prime is equal to 0. The curve has shaped from the gradient positive to negative, increase to decrease. Right? And then point C, local minimum, the turning point where f prime is equal to 0 as well, and the curve has shaped from negative to positive. The gradient, the gradient is negative to positive. Decreasing, increasing. It will give you local minimum. Okay, so for many function, local maximum and minimum is also the global maximum or minimum. Yeah. So here given here x square, y equals to x square, the point 0, 0 is a local minimum and also global minimum. Itu untuk contoh for x square, y equals to x square. You can imagine, right? Y equals to x square, itu adalah local minimum and it is also the global minimum. Ya, sebab dia paling bawah. Okay. Alright, stationary points of inflection. Yeah, so we have here, it is always the true that whenever we find the value of x where f prime is equal to 0, we have a local maximum or minimum. This is the thing just now. Dia tak semestinya when your f prime x is equal to 0, you will have the local maximum or local minimum. It can be also the point of inflection. So look at x cube. Ni kita dah buat dah contoh x cube last week, right? We got the example of x cube dengan negative x cube. So this one, you look at this. If you look at the curve, it is increasing. Below than 0 is increase. Greater than 0 also increase. Betul? Tapi that is not your minimum or maximum point. Betul tak? Okay. So inilah yang kita panggil point of inflection. You nampak tak concave dia? Concave. Yang less than 0 ni, the curve tu shape dia concave down. Whereas yang greater than 0 is concave up. Nampak? Dia berubah ya, the concavity change ya. So the tangent to the curve crosses over the curve at 0 is 0, 0. This tangent is horizontal, but 0 is actually 0, 0 is neither a local maximum nor a local minimum. It is not a minimum point. It is not a maximum point as well. Okay. Okay, so this is what we call a stationary inflection. Yeah, as the curve changes its curvature or shape. Yeah, so it's a stationary inflection ataupun kita panggil point of inflection. POI. Yeah, point of inflection. Okay. Kalau COVID ada PUI, math ada POI ya. Okay. So I guess I need to stop here. We will see further on sign diagram next class. Okay, class. You got to go. It's more than okay. I'll post to you question as your homework in your WhatsApp after this. Yeah.